We all have a story to tell. Let's tell yours. Welcome to the Intellectual People Podcast with your host, Jason. Come together and listen to journey stories and more from interesting people. Welcome your host, Jason.
I often post on various audio forums, and I want to take this time to just thank them. In no particular order, they are audiosciencereview.com, audioroundtable.com, audiocircle.com, audiofilestyle.com, avnirvana.com, diyaudio.com, gearspace.com, and the Parts Express forum. Thank you so much, and I really appreciate your viewership and enjoy. Today on the Intellectual People Podcast, I have Leo from orchardaudio.com. How are you doing today, Leo?
Hi, good morning. I'm doing well.
Very good. Leo, Orchard Audio has made some noise in the audio community lately, and I want to discuss kind of the inception of it and how it came about. Were you always interested in audio and electronics as a young child?
No, not really. Well, I was always interested in electronics. Both my parents are engineers. Obviously, my background, I went to school for engineering and all that stuff. But really, I didn't get an interest in audio until I was working for Siemens at the time. This is like 8 or 9 years back now. And for Siemens, we were designing fire alarm systems. But as part of the fire alarm system, we were designing amplifiers and DACs and other things, so that when a fireman comes into the building, they could pick up a microphone and make an announcement through the whole building. So it's like, it's more of like a PA type system. So that's sort of what got me started into it. At that point, I figured, hey, maybe I can design a good quality audio system for my house. So I gave that a try, and I thought I could do it pretty cheap, but then I soon came to realize designing something that's one-off is actually very expensive. And, especially when it doesn't work the first time around. So I ended up designing an audio system for the house. And then, it's sort of like guests, friends came over, heard it. They were all like, oh, this sounds really good. So I really launched Orchard Audio in 2017, trying to commercialize, what I did for my house audio system. And so Orchard Audio sort of grew out of that.
Okay. And you said you went to formal education is EE?
Yes, I have both master's degree and a bachelor's degree in actually double major, electrical and computer engineering.
Okay. So you graduate college, right? And you're working for a large company, and I presume you enjoyed it. Was Siemens straight out of college?
No, so Siemens actually was not my first job out of college. My first job out of college was with GAL, their elevator controller company.
Okay.
Basically I found out very quickly, engineering is not a very high paying job right out of college. And also New York City is not a very cheap place to live. That's where I grew up. But anyway, yeah, I worked in the Bronx, and I lived in Brooklyn at the time. So every day was like a 2-hour train ride one way to work and then back.
Yep.
For basically what was peanuts. But it got me the experience. So I was there for about a year, and then I went to Siemens, which was much better pay. And I stayed with Siemens for about 5.5 years, basically, doing the development of different portions of the fire alarm system and stuff like that. And then when the engineering work ran out, I moved on. I've had multiple jobs since then, but I'm currently with CACI, which was formerly LGS Labs, which was formerly Lucent, and which was formerly Bell Labs. The company got acquired a lot of times, but essentially, the way I look at it is I'm working for Bell Labs, which was like, a big center for innovation, back, 30, 40 years ago. And there's still some leftover people there, absolutely amazing knowledge and everything like that. So.
And what do you do there, actually?
So I'm designing laser communication systems for satellites, essentially. Yeah.
Can you talk about how it's being used?
Yeah. So the big problem is when you look at the RF spectrum, basically all of the RF bands are saturated. There's really no other frequencies you could run over, or different modulation schemes you can use to add additional bandwidth to the available what's available in the RF spectrum. So the way to bypass that is to transmit light or lasers. That opens up a whole new spectrum of bandwidth that's available. So basically, the technology that the company is doing is this laser communication technology, where two satellites can communicate to each other in orbit, or they can communicate to Earth, and they're actually telescopes set up in multiple locations, because it has to be line of sight, because you're essentially sending light, right? So
Right.
when the satellite is passing over that particular telescope, it can send a beam with data, and the data rates are also much faster than what's available in the current RF spectrum. Like, we're working on systems that can transmit, like 1 gigabit per second, and you're talking about distances of like 250,000 miles, which is, think about of how far you are from like your hub in your house, right? And you only get like a fifth or a sixth of that max, right?
And what is the timetable on completion?
We already have systems out there, that are working. They're not working at those speeds, but everything in the space industry, especially everything that's related to the government, was very slow. So every generation, it's not like the commercial industry where you get a new product every 6 months or every year.
Right.
It's like every 5 to 7 years you get something new up there.
Right.
But actually, space is, with like SpaceX and all that, is starting to become more commercial too than just a government-run entity. So as that becomes more and more prevalent, I'm sure product life cycles will get faster as well.
Do you enjoy that work?
Yeah, it's very interesting technology there. Definitely on the bleeding edge of what's possible. For communication type stuff.
Do you often, when you first started and you really got deep into it, did you go, there's no way this is possible? This is crazy thinking?
Well, the technology was already there when I started with the company. But yeah, when they brought me on, I had no idea this technology existed. But yeah, it's amazing. Yeah, probably like 10 years ago it would have been impossible, but today it's possible. So
Sure.
but that's how technology goes, right?
Absolutely.
Um,
You start Orchard Audio for yourself, right? You start building something for yourself, and friends like it. And when did you realize I should maybe make this a business?
there wasn't like a point where it was like, oh, this is going to be a business now, right? When I got enough feedback that, hey, this stuff is really good, or sounds really good, I decided to try to see how well I could do with commercializing it. And so I had like a Kickstarter project for my first product, and as I learned more and more about the industry, yeah, a lot of my products up to this point, except my latest product, I would say they're like non-traditional products, and so, or in a non-traditional form factor rather.
Okay.
And so for a lot of people that are like very traditional audiophiles, they see something in a non-traditional factor. It's like, well, what is this thing? Can it really do what it's supposed to, and so on. So I think I've had a hard time penetrating the market from that perspective. But I'm definitely, like a non-BS type audio company where my products are based on objective measurements, not so much this subjective. And yes, there is some things that cannot yet be measured, but I believe as technology improves, we'll be able to measure, all these other things as well, to what people call, good audio quality.
Right. Tell me what you mean by not the typical form factor.
Like, for example, my Star Crimson Monoblocks,
Okay.
when they first came out, they had, so I actually have this one pretty close.
Okay.
So this is the size. This is actually a not finished unit. You could see there's the connections missing in the back. So, but this particular model has all the connections on the back. So you have your power, your audio in, and then your binding posts for the output. But when this product first came out, on the back of the unit was only the power and the audio in, and the audio output was on the front.
Okay.
Because it's meant to be put like right next to the speaker.
Mm-hmm.
And make the speaker cables very short, essentially making your speaker like an active speaker, and also eliminating the need for expensive audio cables, like a 6-inch to 1 foot cable to the speaker, and then your power and input on the back. When you look at the audio market, 99% or 95% of amplifiers, have everything on the back. There's nothing on both sides. So, that's like non-traditional in a sense. My streamers, when they first came out, had like the same type of a thing where, some of the connections were on the side, because from an engineering standpoint, it was just, much easier to do it that way. And it was also more cost effective to manufacture things that way. So, I was trying to basically keep the price as low as possible for the highest performance that I can get out of the units. But but my new streamers now, this is the new streamer actually, and it's just the volume control on the front. All the connections are on the back now. But this case is almost double the size because now I have two boards sitting next to each other instead of on top of each other, and so the width is like double. So the case costs me more to make, but my company has become more popular since 2017. So I now sell a lot more streamers than I did a year ago. So even though the case has become more expensive because I make more of them, the price has gone down for volume. So I'm actually able to manufacture this enclosure at the same price as the previous one because I buy larger quantities.
Great. And Leo, if you would explain what that streamer is for the person that might not know.
Okay, so this is a audio network player, and in this particular case, not all streamers have DACs, but this streamer has a built-in DAC. Typically, when you refer to a streamer, it's just a networked device that sits on your network, and it typically has only a digital output. Whether it's USB or SP diff to connect to an external DAC. So that's the definition of a streamer. So this is actually a streaming DAC. So it sits on your network and it has an analog output. And so you can basically plug this directly into your amplifier. This actually will also drive headphones as well. There's some adapter cables that you could plug in, and then you can plug your headphones in. So it'll drive headphones. So yeah, and then you basically control it using your phone or tablet or computer. You basically pull up the app on your phone, and then you can you can connect it to streaming media accounts like Qobuz, Tidal. Amazon is not supported at this time with the software that I use. Basically to keep prices as low as possible, I use open source software that is free essentially. And so whatever functionality comes with it, that's what I'm able to provide to my customers.
For those that use Roon, is that DAC Roon ready?
It's Roon tested.
It is Roon tested.
It's Roon tested, but it's not Roon what is called Roon ready. I'm actually looking into how to make my products Roon ready for the future.
Excellent. And in terms of objective performance of that DAC and streamer, how does it compare to the other products in its range?
Right. Well, I think it's very high performance for its price. So the price is $549.
Okay.
And it has 130 dB signal to noise ratio and 125 dB dynamic range, which I think in its price range, there's nothing else available with those kind of specs.
Could you make it better at $1,000 or less.
Yeah, there are some chips that I could probably use to, improve the performance a little bit. But beyond the 130 dB, like signal to noise ratio and 125 dB dynamic range, there's it's very difficult to squeeze out any additional performance. And is it worth it in the end? It's very difficult
Well, let's
to
get into
say
that.
because most audio systems in people's houses can't even achieve those kinds of levels of performance. Once you include the noise, from like the street or from the AC running in your house, or you'd have to have like almost an anechoic chamber to achieve those types of performance numbers in an actual environment where you can listen to something.
You're familiar with Audio Science Review, right?
Yes, and I'm a member on there. I post a lot of my measurements
Okay.
on that website. Yeah.
The reason I ask, Leo, is that do you think that what Amir does is absolutely fantastic? And again, I commend him for it, right? He invests a ton of money and an incredible amount of time. And I love it. Absolutely love it. Do you believe because objective data is becoming more mainstream then that now we're reaching a point of diminishing returns and at the same time we're chasing numbers that are almost unnecessary? It's more about chasing the lowest signal to noise ratio rather than what's really required to make good music? Or do you believe that chasing those numbers is going to yield not only a better result objectively, but also for what we hear, which is again a very important part of the picture, right?
Yeah. So I mean, I definitely think what Amir is doing is fantastic. There's certain things though I don't necessarily agree with. For example, to compare amplifiers, they use a single chart which measures SINAD at 5 watts.
Okay.
Well, I can, for example, design an amplifier that at 5 watts at 1 kilohertz will outperform everything that's on that chart. But will it sound good? No, because I can make its bandwidth, 2 kilohertz, and then it basically won't reproduce any harmonics, and have a fantastic 1 kilohertz measurement, but sound absolutely crappy because, it doesn't reproduce audio above 2 kilohertz, for example. Just looking at the data at that one number, can you reach a conclusion? Does this sound good or not? It's very difficult. So you have to look at some of the other measurements that he does and look at other things. You can't just
Sure.
look at the one, at the one number, for example.
Absolutely.
But yeah, I mean, we're very quickly reaching a point, where, there's DAC chips out there that can do 140 dB signal to noise ratio. Do we need DAC chips that are better than 140 dB? No, we'll never be able to hear it. So, but there are people that always want the latest technology and the best numbers, regardless of whether you can hear it or not, right? And so.
Leo, why do you believe that North American DAC designers and manufacturers are not currently making a product to compete against the Asian market who has it covered for under $1,000? I mean, their objective data is spectacular, right? The overall quality is great. It's a small form factor. Why do you believe that nobody is chasing that market in North America and able to do it? Because it can be done. We know it can be done. But why is nobody chasing it?
One thing is, if you want to, for example, say manufactured in the U.S., there are certain laws you gotta, follow for that to for that to happen. And manufacturing in the U.S. compared to China is very expensive.
Absolutely.
So doing some of that stuff, is very difficult. In the U.S., you have to pay your employees a lot more than you do in China as well.
Sure.
One reason I'm able to make products with these performance numbers in the sub $1,000 price is that, I have one employee.
Right. No, I get that.
And part of my stuff is also made in China. Like my bare circuit boards are made in China, and then they're actually assembled at an assembly house locally in New Jersey. But and then there's just no getting around it. If I want to stay at these price levels, I can't have everything made in the in the US. And doing the final assembly myself also saves a big chunk of money.
Can we expect a higher level performing streamer at some point with a DAC built in, compete against those Asian products?
Perhaps. Right now I'm concentrating on my amps. This amp, so this is my first really traditional product.
Okay.
Where just the power button on the front.
Yep.
And you have all your inputs and outputs on the back. These amps are going to start shipping in about a month. So I've had a pre-order for these going on the website, at a big discount. The pre-order has actually ended, but you can still, purchase them now.
What amp is that?
This is the Star Crimson Stereo Ultra.
Okay.
And the reason it has the Ultra nomenclature is because my previous amps were called Star. So they both use my Star Crimson amplification technology, which is basically the name for my dual feedback proprietary modulator that I use, along with gallium nitride for the power stages.
Okay.
So my previous amps were only able to put out 150 watts of power, and the Ultra amps can put out up to 500 into 4 ohms. Okay. And so what I'm actually currently working on after this, so this is just a stereo amplifier. You still need a DAC or a turntable or something else as the source.
Right.
But I'm working on actually building my streamer inside this amp. So there's going to be a Star Crimson Ultra integrated, which is basically going to be the streamer and the amp all in one box. So it's your all-inclusive solution. I think streaming amplifiers or these one inclusive units, are very popular on the market now.
Sure. And what will the integrated cost retail?
I'm not sure yet, but the base model will probably be around $3K.
Okay.
So the stereo amp is 2.5, and the integrated will probably be 3.5.
Okay.
And not 3.5, 3. Sorry.
3. Yeah. 3,000 for the full integrated. For the Ultra stereo amp. And the monoblocks, are the monoblocks the same just as the stereo amp, just in mono form, or is it actually?
No, so the monoblocks use my previous modules. So the monoblocks right now are 150 watt amps, okay. But they both use, both the monoblocks and the Ultra, they both use the same modulator, and they both use gallium nitride for the power stages. It's just that the monoblocks use it uses a different gallium nitride solution, which is not able to put out as much power. Okay. So that's why it's limited to 150 watts for the monoblocks, and the Ultra version can do up to 500 watts.
Are you going to come out with Ultra monoblocks as well?
Potentially. But right now I'm concentrating, on the stereo amp and the integrated amp, and then I'll see, how it's going, and if there's really a need for the monoblocks,
What is the advantage of your gallium nitride?
By far, the biggest advantage of gallium nitride is that it's able to switch much faster than the silicon counterpart. So, which allows you to do for Class D amplifiers, which is what my amplifiers are. And one thing I do want to say, I don't really put Class D anywhere on my website.
Okay.
Because for a lot of audiophiles, Class D somehow became synonymous with this is a digital amplifier.
Yep.
And my Class D amplifier is actually fully analog. There's no digital processing in them at all. So Class D equals digital is completely not true. A lot of companies, do use digital modulation techniques in their Class D amps, but Class D by far does not mean digital. Class D just means switching amplifier. Yeah, so my amplifiers are actually fully analog amplifiers. What gallium nitride transistors allow you to do is, because they switch much faster, is they allow you to get a much smaller dead time. So that's the amount of time from one transistor turning on, or from one transistor turning off to the other one turning on.
Okay.
Right? Because if you have two transistors that are on at the same time, you have a problem. You get smoke and all sorts of things happen, right? So you essentially have to make sure that two transistors are never on at the same time. Otherwise, you get the blow up. But with gallium nitride, because they're so much faster, the amount of time between the interval, one turning off and one turning on, can be much smaller than with traditional transistors. And what that allows is for much lower distortion in the amps, because what happens is when both transistors are off, the amplifier has no control of the output. And whenever amplifier has no control of the output, that manifests itself as distortion. So, as that time when both devices are off is reduced further and further, you're able to, get better and better distortion. So that's a big benefit of gallium nitride for me, is that I'm able to, essentially, we're talking about nanoseconds here.
I was just going to ask, is a
nanoseconds, you're a couple of nanoseconds between one turning off and one turning on is almost negligible, at this stage in the game.
Leo, in layman's terms, for the people that don't know what a nanosecond is,
right.
Please tell them.
So a nanosecond is 1/1000th of a second. Yeah, so you're talking about, if we can hear at 20 kilohertz, we're talking about 1 billion here, so going from 20,000 to 1 billion, you can see, that's a very big,
big number.
Big number, yeah.
Can you measure the difference with the gallium versus a standard transistor? Can you measure that difference, and is it an audible difference?
Well, as far as the dead time goes, one thing I can tell you, that if I wanted to design my amps, for example, with standard transistors, they would fail right away, because the other portion of gallium nitride is efficiency.
Okay.
So they the gallium nitride FETs generate a lot less heat or dissipate a lot less power than the traditional MOSFET. So if I were, for example, to just slap even the best traditional MOSFET into my amps, they would fail right away. So because they would overheat.
Okay.
Just from that point of view, can I measure a difference? Well, no, because one won't even work, with the same circuit design.
Right.
So, on gallium nitride, transistors require a completely different drive circuit. So it's very like an apples and oranges type, type of a thing. But gallium nitride for switching amplifiers, is definitely the way to go in my opinion, and presents a much better solution. It's much more efficient, which means you need less heat sinking. It can switch much faster, higher slew rates, everything you want for audio, audio applications.
And the case temperature after your amplifier has been on for, call it, a couple of hours, is at what temperature?
Room temperature.
it runs that cool.
Yeah, they really don't get warm at all. I mean, if they do get a little warm, maybe it's like 5 degrees more than room temperature, you know.
Okay. So it's not the standard of 20 degrees above ambient.
But no, it's not even, you know,
Not
not
even
even close. I have a lot of customers that comment on that. They're like, you know, you can't tell this thing is on, you know,
That's
one way or another.
well, that's a great advantage for the people that certainly live in a hot climate or listen on a second story um, anywhere around the country, because let's face it, it's expensive to cool an audio room. So that's a very, very nice advantage. In terms of sonic character, and it's important for me to ask, I believe, because people always want to know, what does it sound like compared to, right? Class A, Class AB, obviously the gold standard of Class D amplifiers, the Hypex, now the Purify, right? All Bruno designed. So is your amplifier, would you say it is more sonically like a Class AB, or does it even have its own character?
Maybe I should get more into what my design philosophy is than
Please do.
that, you know, because giving some, you know, it's very subjective, right? And
Absolutely.
a lot of people, I actually have a lot of customers that like tubes, and from a technical perspective, you know, tubes are clearly subpar to what we have today. They generate this second order harmonics and they make this warm sound, but you know, a lot of people love that sound, and so
Right.
they buy my amplifiers and they connect it to a tube preamp because they want that tube sound. You know, if you only have my equipment, you're not going to get that second order harmonic sound that, you know, tube lovers go after. You know, so, but my design philosophy is that I design, or um, I try my hardest to make the product as transparent as possible. So like if you look at the frequency response, it's completely flat. You know, and it's it goes all the way down to DC. So there's no bass phase shift in my products, for example. You know, the high frequency, there's no high frequency roll off, which you get with a lot of other solid state type amps. So, you know, in the audio band, you know, I would say my products are, you know, as transparent as I could get them.
Okay.
Right. So if you want coloration from your, you know, or you like some type of coloration in your system, you know, then you put in like a tube preamp, or you know, you put in an equalizer, you know, to boost the mids. You know, some people like mids more, you know, stuff like that.
Sure.
But my products aim to be as neutral as possible. You know, and then if you want to go after a certain type of sound, you know, I leave that up to the user, or you know, up to the artist, you know, how they recorded,
Right.
you know, their track and how they want that to sound, right? But my ideal is, you know, basically gain, like flat wire with gain, right? That's the like audiophile ideal. And and you know, and while this audiophile nomenclature, I think has become almost of like a stigma in the industry, right? But the basic principle of it is flat wire with gain.
Yep.
You know, and that's what my products aim to achieve without any of the other BS that has become associated with the audiophile word. Right.
Leo, do you believe that there is a direct correlation on what you measure to what you hear?
Definitely. Like I said, you know, there's clearly certain measurements correlate very, very clearly with what we hear. And, you know, there's also two amplifiers that, for example, measure the same, won't necessarily perform the same, right? Or you won't sound the same, because there's still a lot of things that we don't measure, or there's no measurement yet designed for certain aspects of it, right? Because
Okay.
yeah, you can have two amplifiers, you know, with 100 dB synad, for example, but they won't sound the same because there's a lot of other things that don't get measured, you know, transient response, and you know, I can name a big list of measurements.
So tell us, I should say, what measurements, if you would, correlate to what we hear, right? So which measurement do you believe that when you take X measurement correlates to what we hear?
Yeah, so that, it's very difficult, I think, but definitely harmonic distortion definitely correlates to what we hear, because we're gonna, we we hear harmonics, right? So if the amp is producing distortion, like for example, with tube amps, right, they clearly have a second order harmonic that they add to the audio, which you can clearly hear. That's what they call the warm sound. So in this one particular case, harmonic distortion definitely correlates to something that we can hear and easily easily pick out, right?
Where is Orchard Audio going? What is the plan for Orchard Audio?
My idea is to basically make the best objective performance products at the lowest possible price. So that is what I am trying to do, right? So I'm using state-of-the-art technologies like gallium nitride transistors, and that stereo amp that I showed you, the pre-order price was $2K. So I believe this is the least expensive gallium nitride amp at on the market. If you look at like Merrill Audio and Technics and AGD, their gallium nitride is selling for like 10K minimum, I think, I believe. Right. So I believe I'm basically getting the best subjective performance for the lowest price possible. Now, I of course understand that even at 2K for a lot of people is very expensive.
Sure.
Right. But as Orchard Audio grows and, my products become more popular and I'm able to manufacture in larger volumes, I will continue, dropping my prices. So yeah, so, my plan is to continue using state-of-the-art technologies, and offering them at the lowest price that I can, which is typically not the way that it goes. Usually state-of-the-art technology means prices are up here, right? Which you could see with a lot of other manufacturers, right?
Yep. I want to go back to the streamer for a second. A very popular low-cost solution is a Raspberry Pi 4, and it runs pick whatever software you want to use, right? Is your streamer designed by you, or is it an off-the-shelf Raspberry Pi that you've built a DAC hat basically for?
Right. So my streamer actually uses the Raspberry Pi 3B.
Okay.
Because the Raspberry Pi 3B generates the least amount of heat from the other models, like the 3B Plus and the 4. The 4 generates a lot of heat, and actually it doesn't really offer you any better audio performance than the 3. So I use the Model 3, to keep the heat down. And the DAC, which is the PecanPi DAC, and the reason it has the Pi in it is because of the Raspberry Pi, so it's easy to associate the two. But the DAC is completely my own design.
Okay.
Right. So I use the Raspberry Pi and I pair it with my DAC, which is my own custom design, right? And then I put it all into a steel enclosure, which is what becomes the streamer. And I do offer multiple software options. Volumio, Ropey. Ropey is what I use for the Rune endpoint solution.
Mm-hmm.
For those that I don't call it Ropey. A lot of people don't know what Ropey is. I just call it Rune endpoint. That but it's Ropey is what's running on the streamer, for those who know what Ropey is. And then there's the Pi Core Player option, which is essentially it becomes a squeeze box. So my streamer becomes like an ultra high performance squeeze box. Well, compared to what squeeze boxes were 10 years ago, if you're still using, Logitech Media Server and you don't want to get away from that, you can get my streamer, replace your squeeze box, and get something that's a lot higher performance for about the same price as what the squeeze box was actually, right?
And is the DAC fully balanced topology?
Yes, it's a fully balanced DAC. It also, for those that don't have XLR connections in their system, it comes with XLR to RCA adapters, so that those that have RCA can still use it.
Out of the box, they're ready to go.
Out of the box, yeah, it comes with everything you need for both XLR, for fully balanced, or RCA operation. Yep.
Gotcha. How do you work with Ropey? Because it's freeware, but he obviously he depends on donations, right, to improve the software. Got to be realistic about it. So do you have a deal with them where for every unit you make a donation, or do you leave that up to the consumer that buys your product that they would make a donation?
I gave the creators of Ropey a few of my DACs for free for them to integrate, my DAC into their software. So beyond that, I haven't done anything yet, but I am in talks with them about what it would take to make my products Rune ready instead of Rune tested, and then that involves, that's a very large effort. So there's some upfront cost, and then there's also, going to be some licensing fees that are involved for each unit that I sell at that point. But that's an ongoing. I can't say for now what the time frame is for having my product be Rune ready versus just Rune tested.
Right. And we should also mention that Ropey is I believe that Ropey is a Rune ready approved software, isn't it?
Yes, I mean, Rune works very closely with Ropey, and Ropey does run on a lot of Rune ready devices that are based on the Raspberry Pi. There's other companies that use the Raspberry Pi inside their products with Ropey that have went through the process that I'm in talks with them now about being Rune tested. So as far as Ropey being fully supported by Rune, absolutely.
Right.
But yeah, the Rune, you can't really label it as Rune ready because only a finished product can be labeled as Rune ready, not like individual bits and pieces.
And as you've mentioned, Ropey is very tight with Rune because Ropey even has their own little section on the Rune Labs forum, right?
Yes, they do have their own section. They're very close. I believe they're actually the only approved company that is able to produce Rune ready software for the Raspberry Pi. I don't think there's any other company that does it. So,
and I have to say, as a user, it's remarkable. It truly is remarkable. My favorite feature, auto updates, and it actually works. It works. 3 a.m. every day. It reboots, and if there's a new update, it automatically loads it. It's fantastic. I love it.
Yeah.
Leo, is there anything that I haven't asked you that I should have that you would like to share?
I mean, if you want to talk a little bit about my childhood, I guess, but
we've already.
Other than that, not really. My parents brought me to America when I was 8. We came over from Belarus, which was in 1993. I just gave away my age. They wanted to provide like a better life for me here, which I think I've accomplished.
Why Orchard Audio? Why the name?
So I love apples, and apples grow in orchards. So it's sort of like, okay, I'm gonna call my company Orchard Audio. So now, my first product was called the apple pie. And as you can imagine, I quickly ran into trademark troubles with a certain company. My initial Apple style thing did not work out very well due to a certain company. And anyway, but my products are otherwise currently named and will be named after things that grow in orchards. Pecans grow in orchards. My Star Crimson is actually a type of pear. So pears grow in orchards, right? And as my product lines evolve, where I get additional product lines, look for, names that, of things that grow in orchards.
Fantastic. Well, Leo, I really appreciate it. And I appreciate your time on this Saturday morning that we're doing this at. Thank you so much.
Okay. Thank you very much. Have a good July 4th weekend.
You too.
Thanks for listening. Find us on YouTube and Facebook at the Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.